Well, hello everyone, and welcome back to Adrian's Digital Basement. I have the Apple IIgs on the bench here, and that's because I want to do a repair on this Apple IIgs motherboard that was sent in for a mail call episode several weeks ago. This motherboard has two issues I want to address in this video. One is it's got some bad memory. I need to try to figure out which chip is bad and swap that out. And next, it has ROM version 0 on it, which limits compatibility quite a bit. So I want to try to figure out how to update the ROM on here. Now it uses a custom chip, so it's not going to be as easy as just swapping in an EPROM. So without further ado, let's get right to it. Okay, I have my good Apple IIgs here on the bench, so I wanted to run the diagnostics on this machine first so we can see what a successful diagnostic looks like on the Apple IIgs. If you recall from the mail call episode, the motherboard from Mike didn't pass its diagnostics, which gave me an idea of a fault. It also had trouble running software, it would crash and do weird things. So that was a little bit of an indicator as well. Let me remove the lid from this IIgs. So this one is a little decked out compared to maybe the average one. Ooh, the power supply's a little bit warm. It's been running for a bit. I have the Apple SCSI card in here, and this is the more fancy SCSI card that actually has DMA. So it's relatively fast. In addition, if I turn this off, it also has a RAM expansion card, which, how big is this thing? 4 megabytes maybe? Yeah, 4 megabytes. It's funny, the original RAM expansion card was quite big, could only add 1 extra megabyte to the machine. So that plus the 256K on these older ones gave you 1.25 megabytes. But of course, this little tiny card gives you quite a nice expansion. You can find these on eBay relatively cheaply. It's marked Garrett's Workshop 4 megs RAM, and I think it was like $30 or something like that. An absolute great value. I really recommend getting this card. There are bigger cards out there, like 8 megabyte ones, but is that really necessary for a IIgs? I have the IIgs connected through the open source scan converter here, so we're getting an image and therefore we're getting a capture as well. I have a keyboard, and if we hold down Option, Command, which is Open Apple, Close Apple, Control, and Reset, this should initiate the diagnostics. Here it goes. So you'll get this changing patterns and whatnot as it tests the various memory banks and stuff like that. It switches modes into the high-res 2GS color mode, back to the regular Apple II modes. And at the bottom of the screen, you'll see it says 0, 6,000, 7,000, 8,000, is sort of changing. Those are the phases of this diagnostic test that's running. And we'll take a look at what those mean in just a second. And it ends with a system good. Okay, so that's a working test. Let's switch to the other motherboard that Mike sent, and we'll run a test on that one again. I only have one power supply, so I'll have to be using this one here to test the motherboard from Mike. All right, everything is connected. Let's power this on. No speaker. Let me grab a speaker just so we can hear that running. I'm just going to use a normal, I don't know, this is from a monitor or something. I always save speakers whenever I see them, and I'm sending something to e-waste. We're not getting anything because the power supply is not connected to mains power. You really do need that to get any operation out of your IIgs. Okay, here we go. Let's try again. Okay, normal sound. And we have check startup device. Now, one thing that's interesting, and I wonder if this is something to do with the fact that this is not in a case, and maybe it's having a grounding issue because of the shielding. Does everyone remember that problem I had with the shielding on, what was it, the Color Classic, where the sound didn't work if it wasn't shielded properly, and I had to solder some bridges together. I also had a similar issue on the Apple II Plus. The RFI version of the board has some pretty bad ghosting in the image quality, and that's because of a split ground plane thing going on by Apple. I honestly wouldn't be surprised if that's happening here, because see this metal shielding that's on the connectors here? This in the normal case is actually touching the shielding that's in the case, and the power supply is doing the same thing. So let me take this power supply and touch it to the metal right here. And look at that. All of the waviness on the image is gone. And when I remove it, it's back. So that's exactly what's happening here. Again, Apple, they utilize all that shielding as something that completes the ground plane. And right now I have a feeling we have a ground loop happening from this video connector here through the open source scan converter and all the way around. Very frustrating that happens. I'm just gonna add a clip lead between the power supply and this metal here to take care of this interference problem. Okay, we're booted back up. Let's boot into the diagnostics again and see the failure on this board. Okay, you can kind of see a problem right away. Okay, so there's the bad error sound, and it's O2E0 2000. I'm going to write this error code down, 02E0 2000. So I'm going to rewind the footage here, but when that diagnostic was running and it was showing a pattern on the screen, I noticed that the repeating pattern had little extra pixels that were dark, so to speak. It was definitely showing up as a bit error that wasn't showing up when I tested it on the good machine. So that was sort of a visual indicator that there was actually a problem as well. Doesn't really help us narrow down exactly where the bad RAM chip is, but the fact is that this code that just popped up will help us to some extent. All right, so I Googled around looking for documentation for the Apple IIgs, and I found several very relevant documents. First is this Apple II technical notes, and it is the diagnostic error specifically. And this was something that was put out by Apple, most likely for their dealers to help figure out what was wrong on the board. So it talks here a little bit about those error codes that pop up, and they're in the format of AA, BB, CC, and DD. So looking at the code that I just wrote down, AA is 02, which shows up right here as a RAM test. The second two digits is the bank number, which is E0 in this case. And then CC does talk about which bits failed. So that's this that was 20 in the test. These last two zeros are irrelevant. Now when it says 20, what does that exactly mean as the bit failure? We'll get back to that in just a second, but the next step is to take a look at what is using bank E0. What is that RAM specifically? So again, to Google, I found the Apple IIgs hardware reference manual, and it's kind of like the service manual, but it's more about how to program the Apple IIgs. It's not so much about technically how the chips are all connected. It's really all the registers and the memory maps and how you're going to use all the advanced capabilities of the IIgs versus a regular Apple II. And here is figure 2.3, which is the Apple IIgs memory map. And sorry, it's a little bit blurry. This is like a scan from a book, and it's just not that clear. There are two types of IIgs, a 1 meg version and a 256K version. The 1 meg version is the ROM 03 version. I don't have one of those. That has a megabyte of memory on the main motherboard. Both of the IIgs I have, this one from Mike here, and my actual IIgs are the 256K versions. So we know that bank E0 is the one that failed, and right here it is, E0 and there's E1, slow RAM, controlled by the Mega 2. Well, taking a look at the actual motherboard here, it says standard RAM here, and it says fast RAM here. And then this chip right here is the Mega 2, and it does say Mega 2 right there. What the Mega 2 is basically is the entire Apple IIe, except for the processor, on a single chip. That's right, Apple basically combined everything together from the old Apple IIs into this single chip. So it's really what makes the IIgs fully Apple II compatible is it literally has an Apple IIe on the motherboard in this chip. And incidentally, the Mega 2 is also used on the Macintosh Apple II compatibility card, the one that goes in the Color Classic and the Mac LCs. It's using a Mega 2 and it interfaces that to the Macintosh for like screen updates and I/O input and output and stuff like that. If we look here at the screen capture, we have the Mega 2, and it is connected to a chip called the Slot Maker, which allows these slots to work. It connects to the 128K of RAM, which is going to be this standard RAM right here, which is that bank E0 and E1. It hooks up to a video graphics controller chip, which is what gives the Apple IIgs the additional graphics capabilities that the regular Apple II doesn't have. But keep in mind, the Mega 2 is what generates all the Apple IIe and IIc style graphics, and the video graphics controller chip only handles the 2GS modes, these extra modes. And funny thing is, the color display you see on a 2GS when you're in text mode, that is actually not generated by the Mega 2. The Mega 2 is outputting normal Apple II monochrome graphics and text, and it is the video graphics controller that is literally taking that and applying color on top of it. So say you change your text color to purple, well, it's white text that's coming out of the Mega 2, and the video graphics chip after the Mega 2 applies the color, and the background color and the border color. It's kind of funny that that capability was added, but it was. So the Mega 2 has its own RAM for running old Apple IIe software, and then this additional RAM over here and what's plugged into that slot are totally used by the Apple IIgs specific software. And when you use a 65C816, it addresses all that additional memory with a 2-byte bank, and it's all banked into 64K. That's kind of how it's working. Now, if we look down in this section on the board, you'll see the additional 128K of RAM that's on my particular versions of the 2GS. The PFI or FPI chip there, that's sort of like the memory controller chip. It's also connected to the ROM that's on the motherboard and the expansion slot. It's sort of handling all of that additional capability that is 2GS specific. And hanging off that is the processor as well, the 65C816. So we know from the diagnostics, well, maybe didn't get to that point, I don't know, but I think this RAM is okay. All of the RAM problems exist on the RAM that's hanging off of the Mega 2. Okay, so we've identified that the RAM that's problematic is this RAM down here, but there are 4 chips here, 64K and 64K. Which of these chips are the problem? Now, from the diagnostic code, it said bits 20, and I assume these are hexadecimal bits, so 20 hexadecimal are the problem. But what does that mean exactly? Apple could have been a lot more specific to say that when you saw 20, it specifically meant that chip, or this chip, or even talked a little bit about how the addressing specifically works to these chips. But unfortunately, they didn't. Now, luckily, there are also copies of the Apple IIgs schematics online. If you just do a Google, you'll find them. And right here on page 2, we have the Mega 2. So this is the Apple IIe on a chip. And it has 4 of those RAM chips that hang off of it. And here they are. We have UM2, UM1, UM4, and UM3. These are typical 4464 DRAMs. Basically, each chip has 4 data bits, 64K each. So you need 2 of them to make 64K of 8-bit memory. And there are 2, and that's really because if you think about the Apple II originally had 64K, well, like the Apple II Plus when you had the memory expansion, but the 2E and the 2C added a whole extra shadow RAM, an auxiliary bank of memory, another 64K, that enabled like the 80 columns mode and the double high res, and software could bank switch that auxiliary RAM in and use that memory for additional storage. I've been looking here, and the Mega 2, which is this chip here, has 2 outputs for CAS. That's the column address select. It has A and M. I'm assuming M is main and A is auxiliary. And I'm going to make a guess that M for main maps to bank E0, and that A for auxiliary maps to bank E1. And looking at the CAS M or main line, it runs over here and it goes to these 2 chips right here. So it goes there and it splits off to there, and that's UM4 and UM3. And if we look at the motherboard here, it's these 2 chips on the right. So I'm going to put an extra little mark on both of these chips here just to indicate that these are the two that I have a hunch are bad. Now, one thing I know for sure is this machine does sort of work, and it only has some small errors in the memory. If there were entire data bits that were dead, there's no way this computer would even work at all. So some of the problems I've seen in the past is, yeah, like one of the entire bits is just completely dead. So instead of 8 bits of memory, you have 7 or 6. And a computer really can't function because you're not going to be able to run machine code when you have problems like that. So I think the problem is that there are specific bits of memory in the entire 64K which are bad. And if we go back to that diagnostic pattern where it was showing the graphics there were repeating dots that looked bad, but certainly it wasn't entire columns that were missing or entire rows that were missing, which would indicate more fundamental problems with this memory. I have another idea on how to turn that 20 code for bits into some usable information. And up here in the Windows calculator, I've entered in 20 hex, and that gives us a bit pattern. And we can imagine there are 8 data bits, 0 through 7, right? So that's 8. And it's saying here that this is potentially the bad bit. That's how I'm kind of translating this. So that would be bit 5. If we go back to the schematic here, these are the data bit outputs here. So 0, 1, 2, 3, 4, and 5. So UM3. That hopefully is actually the chip that is bad. So I'm going to draw a big circle on it as this one right here. So I think at this point the logical next step is to yank this chip out of the board. I'll install a socket, we'll pop a new one in there, and we'll see if this problem is fixed. All right, the RAM chip has been removed. Here it is right here. I have not tested this computer yet, so let's see if this thing actually works. So first let's test to see what happens if we try to power it up without the RAM chip installed at all. It will kind of confirm my hunch that it's not going to work at all. Let's just give it a try. Okay, power up. Okay, very unhappy Apple IIgs. This is what happens. It's running, it is running, but it's very, very screwed up. I don't have a 4464 chip handy, so I'm gonna steal one off my VGA card here, which I know works. These are good chips because I use this card all the time. There we go. The notch is in the correct configuration. Let's power this up. See if this thing works better. All right, we got the check startup device, which is completely expected. Let's reboot this and let it do the RAM test. I'll plug the speaker back in so we can hear that horrible diagnostic sound if that does come up, the one where there was a problem. Okay, I am seeing that dot still there. That means that there's still a problem with the RAM. There it is. So I definitely made a guess that it was this chip that was bad. Now, 2 guesses, right? I was guessing on that bit 20 meant it was that bit that was on this chip. But the whole, which bank was it, E0 or E1? I assumed that the CAS-M meant main bank, which would have been E0, but it could well be this other chip here. So I'm just gonna double check on the schematics to make sure that that same bit talks to this chip here and hope that that's the problem. Now, just as a caveat here, I could have just removed all 4 of the chips or put sockets in and then just figured out which of the chips was bad. But I like to understand what the actual problem is and not throw the so-called parts cannon at the motherboard, just swapping out parts left and right, if we can actually figure out what the problem is. Now, if everything was socketed, no problem, we just swap chips out. But these require actual desoldering work, and every time you desolder, you can damage the board. So that's the danger. All right, I'm gonna go check the schematics to see if that same bit, I think it was bit number 5, is on which of these chips for the other bank, and I'll take that chip out next. All right, the next socket is in. The schematics confirm that bit number 5 was this chip here. Let me pop in my known good one here. I put the original one that I removed and it's back in the socket, so that's on the motherboard. This was the one that I think might be bad. Let's see if this is the case. Let's plug in the speaker again, but the computer is booting. It's a good sign. Let's reboot this thing with the diagnostics. Here we go. I'll know pretty quickly if I see those extra dots. I think that's it. No dots. So it was this chip right here. So it should run through the rest of the test now. Yeah, I think it's already gotten further than it's ever gotten before. Oh, Apple. You could have just told us which of the banks E0 was and which was E1. Why did you make me have to guess? So I guessed and I guessed wrong. System good. Now, one thing that's interesting is there was no ramping up test tone that the other one was doing. And I assume that's because this is ROM 0 and that one is ROM 1. So system good means at least this thing should be working. Now it's time to try to swap out this ROM with a new one. So this IC here, this is the ROM. Now, I think it's 128K. But the problem is that it's in the same footprint here that probably maxes out at 64K with a regular EPROM. This EPROM right here is a 256K EPROM, 27C020, I think it is. And it's too big to fit in this socket. It's got, I think it has 4 extra pins, and those are gonna be address lines. So I'm gonna have to make an adapter to go from this to this socket, and then this should work, this chip. Now, of course, that means making an adapter with a couple sockets stacked on top of each other and running some wires around, you know, one of those kind of janky adapters that I do. There's probably a PCB-based adapter for the 2GS that has like a surface mount chip on it and the pins, and it all goes in very easily. But I don't have one of those. And I want to get this thing upgraded to ROM 1 so I can actually run some software on it. Pretty much nothing really works properly on ROM 0. I noticed I tried to boot GSOS and it's like, it requires ROM 1. The ROM in the 2GS actually holds quite a bit of the operating system for the GSOS OS. GSOS OS? The GSOS. And that means any game or software that uses those libraries that are built into the ROM, they just don't work. So swapping out this ROM is kind of imperative to get this thing working. Now, I could just take the ROM chip off the other machine, stick it in here, but I'd like to get this board working with ROM 1. This will be useful for anyone out there who doesn't already have ROM 1 on their machine and they're stuck with ROM 0, and you want to try to use an EPROM to upgrade it to ROM 1. All right, adapters. So Reactive Micro sells an adapter. You can just go to their website and buy it if you so desire. There it is. It is a little PCB with a surface mount chip on it. And it looks like they made some adapters using stacked ROM sockets, which is exactly what I'm about to try to do. And yeah, but they don't sell these anymore, I don't think. I think they're calling this the version 2.0. So anyhow, I need to make one of these stacked adapters and use an EPROM. Luckily, this Apple II box.de, they made the instructions that you need. The only thing is they're talking about using a 27C1001 EPROM, and the EPROM that I have specifically is a 27C020. I got a bunch of these chips here. Look at these, tons and tons of these. They came out of Cisco devices, I guess a router. I think I looked these up and they're 256K each. I have one of these in the eraser right now. I have on screen here the pinout for the 27C020 compared to the 27C1001. There's not a whole lot of difference. We have pin 30, which is not connected. Pin 1, which is VPP, but is A19. Pin 27 on the motherboard goes to pin 29 on the chip, which is going to be address line 14. And that is the same here on the 1001. There's address line 14. And then 15 and 16 are in the same exact position on the 020 chip that I'm going to use. So really, I'm just not going to connect. Well, I think I'm going to ground pin 1 here, which is address line 19. I'm going to ground 30 and 31, which is 17 and 18. I know it doesn't sound completely clear the way I'm explaining it, but basically we're just going to wire it up exactly like this, but the pins that are in blue here are the ones that aren't going to be used, and I'm going to ground all of those. Well, I have this socket, which is going to go in the motherboard, and then I have these pins here, which will plug in, and there's going to be 2 extra overhanging pins. Well, any pin that goes from this into this that I don't want connected, that is specifically pin 28 here going to pin 30, I need to cut the pin on here so it doesn't make contact with the pin there, and that way I can connect them together to do that grounding I was talking about. Okay, the adapter is complete. So the large EPROM that's 256K plugs into the top part, and I have little bodge wires that rewire it as necessary. Now I'm glad I didn't just fully trust this thing I found online here for the 27C020, because there were too many address lines on this particular EPROM. This would make it like 1 megabyte, I think, something like that. So I'm glad I went and double checked the data sheet. So this is the data sheet for it. It goes up to address line 17. And that's opposed to this one, which has an 18 and a 19. That's the program pin and the VPP pin. So when you wire up the adapter, you don't actually have to hook those lines up to anything. VPP and the PGM line, they're only used for programming, so you can leave those floating. But for address line 17, which is not used on the Apple IIgs, it only goes up to address line 16, which it's rewiring from this pin here up to there. So 17, I do have to ground on the new EPROM, on this adapter here. Otherwise, it could accidentally select the wrong half of this EPROM. So of course, you could put 2 copies of the ROM in here, like ROM 0 and 1, and put a little pull-up resistor with a toggle switch to ground, and you could select between the 2 ROMs with this. But I don't really need to do that because, like, why would I ever want to run ROM 0? And I can't run ROM 3 on this motherboard. It's just not possible. Only ROM 01 and 00 are possible. Anyhow, so I grounded address line 17, and then the other 2 are floating, and I did the rest of the rewiring. So this chip now has been programmed for ROM 01. So let's install this into the socket here, or into this adapter rather. Ooh, why is it? I might have a bent pin here. Now I did go through everything on this adapter, checking to make sure that none of the pins are shorted together, that ground goes to the right place, that VCC, which goes from this pin here, goes up to that pin, and it's not connected. There's a couple spots right there and right there, or I had to cut the pins, and I just wanted to make sure there's no short. So anyhow, that is all in there correctly. And now we have to put this into the ROM socket. Now there is no notch on this socket, but there is a marking on the motherboard there with the silk screen that I can just see the notches down here, which is opposite of the CPU, which has been flipped around. And this RAM has the notch up as well. But for whatever reason, they put the notch down on the ROM chip. Now, if you're not sure about that, I'm going to put this in without powering this on, and I will check to make sure that the ground and the 5 volts are in the right spot on this EPROM. There it is, the little stack is in the motherboard. Okay, with the chip in with the notch down towards me, this pin here, this is going to be 5 volts, and this pin down here is going to be ground. So on the power connector, ground is these 2 pins right here, and that is correct. And this pin up here is 5 volts, which should be one of the other pins. Not sure which one. That one right there. There we go. So it's definitely not in backwards. And that beep when I touched the 5 volts to ground was just the capacitor on this board. All right, we're actually ready for some testing now. I have everything plugged in, just double check. The old ROM is here, the old RAM is here, and here we go. Oh no, we have no nothing. So that's weird. Let's just put back the other ROM really quick. Okay, that is definitely starting up. So there's nothing damaged on the computer. I wonder what's going on. You know what? This socket here, unfortunately, this one here, this is one of the sockets I hate. They just don't make very good contact sometimes. So I'm going to put this back in here, and I'm going to really push it down hard. Yep, in fact, I can see right now that it's popping out of the board, so I'm gonna have to take that socket out. I'm just gonna push down on it and we're gonna turn on the computer and see what happens. Oh, we still got nothing. Okay, I swapped out the socket. This is the original socket right here. And the funny thing is, I could not get this thing to work still. It just would not do anything when I had my EPROM in there, but switching back to the original ROM, it worked fine. I spent a ton of time double, triple checking all my wiring on the adapter. I broke out the oscilloscope just to make sure that the chip was reading properly. And a good test for that is you stick a blanked EPROM in there. And when you do that, the outputs of the EPROM will be high on every single address. And I hooked up the scope to the chip select line. So when that went low, I expected to see high on all the outputs. And I did. But when I put in a programmed chip, where I programmed it with ROM 1 that I downloaded off, I don't know, one of the various websites, I went and got like 5 different copies of it just to make sure that the one copy I had wasn't bad. Well, when I checked with the oscilloscope, all of the outputs when the chip was selected was low, which meant the computer, what it was reading out of the chip was simply all zeros. And when you first turn on the 6502 based computers, it goes to like the reset vector, which is like FFFC or something like that, and it reads the address where it should start executing code. So you shouldn't have all zeros. That's definitely wrong. That was telling the processor to go to the bottom of memory to start executing, which clearly that's not going to work. So that definitely told me that the code that I loaded into the EPROM was not right. So I started doing further Googling, looking for ROMs to download, and I found this page here, which seems to have a dump of like every 2GS ROM. We have 0, 1, we have 3, and I don't know why there's like different versions here, different banks. I'm not quite sure. Maybe there's 2 chips that make up the ROM on that later 2GS as opposed to 1 chip. There's also a BT ROM, whatever that is, and an Alpha ROM. So anyhow, I downloaded ROM 01 from here, and right away, I could see that the code that I had just loaded off the disk, let me load the other file, looked totally different. So all these like Apple IIgs ROM, these are all different copies of the same ROM. When I load this, notice it looks different. It's C230A2. And when I open up the actual one here that I just downloaded, looks totally different. So I'm not really sure what's going on here, but obviously, whatever the emulators are using, which I think is the files I had downloaded for 2GS emulators, is different than what's actually in the ROM. So those dumps that I just found, that I showed the screenshot of there, where obviously someone had hooked up one of the ROMs into an EPROM reader and read the content directly out of the chip, as opposed to using software on the Apple II to dump the contents of ROM into a file, which I think is how the other ones were produced. So I just programmed that chip and I stuck it into here. Let's see if this computer now works. All right, I have the speaker hooked up. I am gonna power this up and let's listen for that bong or dong or whatever the noise that the 2GS makes when you turn it on. Here we go. Oh, there it is. ROM 01 showing up on the screen. It actually works. Let's reboot that computer one time again. This is weird. I don't remember ever seeing this before. Enter the control panel for 1, set system standards to 50 or 60 hertz. Oh, I just realized now what I was doing. I wasn't pushing open Apple control reset. I was pushing closed Apple control reset. I honestly did not know that that was how you could get the computer to run at 50 hertz. Let's just hit 3 and see the computer running in PAL, I guess. And there it is. It's running in PAL. Look how big the border is on the bottom. Wow. But you can switch back by doing that same sequence again. So we're gonna do 60 hertz, 2, and that swapped over into 60 hertz. All right, let's just run the diagnostics one more time with the ROM 01. Maybe it's a more thorough diagnostic or something like that. Let's see what happens. There we go, system good, and it made that tone, so that obviously is ROM dependent. Okay, let's run some software on this machine just to really put it through its paces. I'll use the floppy emu for that. I have some 2GS software on this. I will put in my RAM expansion card into this thing because some stuff needs more memory than the built-in 256 here. Okay, 16-bit, let's see, I think let's load GSOS. All right, here we go. Ooh, you can ignore that jitter. That is the capture device. It is not set up to capture the pixel clock of the Apple IIgs specific modes. When the 2GS switches between Apple II and Apple IIe graphics modes and the 2GS mode, the pixel clock actually runs at a different speed. It's slightly different output, and it's funny, as it switches, the monitor here blanks out. I think it might blank out a little bit on the capture as well, but that's what's causing this jittering. But system 6.02, this would not load at all before when the RAM was bad. And then and I know it also would not work without ROM 01. It's definitely required for any system past version 4, I think. Anyhow, we have a working machine here, so there it is. I booted the system disk. And yes, if you haven't seen the Apple IIgs operating system, it's not bad. It's really not bad. And don't forget that this is all running on a computer that's like 2-point-something megahertz. That's it. And yet, it's pretty functional. It's definitely on the slow side. Like, notice when I update this window, how long that takes to draw. Like if we move it off screen, move it back, it's not exactly great, but it does work. And when you have an accelerator on the machine, it's pretty fantastic how actually fast the Apple II is. Incidentally, here's the memory here. Total memory, 4,352K. So this game is actually booting, and notice it's using the welcome to the 2GS screen here. So it's actually loading the GSOS. Some of those routines are in ROM, so that helps not take up memory on the machine. That can mean that this game may not work without ROM 01. Funtime Arcade, there it is. While we wait for this to load, I am going to stick a label on this ROM chip. Apple IIgs ROM 01. Speaking of loading, that's one of the things about the 2GS. I mean, I had one of these computers as a kid. What's pretty annoying is that things took a long time to load a lot of times, at least off the disk drive. I mean, the 3.5-inch Apple disk drives weren't terribly slow, but these games just seemed to be very inefficient at loading. I don't know what it was. They just took a really long time. Some games like Stillfeed from Sierra was unbelievably slow, and you had to swap disks around. Luckily, games like this one, I think, because it showed that welcome to the 2GS screen, I think could be copied onto a hard drive. So I did have a hard drive as a kid. I got one later. It was 20 megabytes external hard drive. And it made these games a lot more playable than when you're doing them off disk constantly. But I think there was a lot of trial and error to, oh, here it is, it just loaded up. There's a lot of trial and error to figure out what actually worked off the hard drive and what you had to boot the disk. Games were cracked, you know, it was all over the place. It wasn't super easy. Should be sound. Okay, there was music and I aborted out of it. So there it is, Arkanoid. Looks pretty good. Remember, as I said, 2-point-something megahertz this machine. Whoa, nice 60 frames per second. Oh, I got the laser. Oh, and I just died. Nice smooth animation. There's that music as well. This thing has like a Ensoniq synthesizer chip in it, so pretty capable sound. So the Apple IIgs, it was quite a capable machine that Apple hamstrung by giving it not enough megahertz. There are lots of other videos talking about that. Maybe I'll make a really nice retrospective on the 2GS one day, as it was one of my favorite computers, well, up until I got my Amiga, and that became my favorite computer. I went from the 2GS to the IBM PC at the same time, and then I got an Amiga, and I loved my Amiga 2000. I had an accelerator in there, SCSI hard drive, flicker fixer, so I could output 31 kilohertz video. The Amiga was an amazing computer, and it got me through college. Then PCs took over with Windows 95, and the rest is history. But for many years, I loved my 2GS, and it was very capable in many ways. I had the Transwarp GS as well, back when they were actually affordable for the machine, and I couldn't believe how fast it made the computer. Just unbelievable. But then the Amiga, of course, blows away the 2GS with all the processors. And to think the Amiga's, similar age to this, right? This came out in '86, and so did the Amiga. The Amiga was leaps and bounds ahead of this thing. Of course, though, you didn't have that backwards compatibility with the Mega 2 chip, as we talked about. So anyways, different machine and a different subject. So that is going to be it for this video, the repair and upgrade of the 2GS motherboard from Mike. Thank you very much, Mike, for sending that in. And of course, thank you very much, Brett, for sending in these EPROMs as well. It's great to have these because I actually don't have a single other EPROM of this large size, and this made this upgrade possible. Oh, something else I forgot to mention. So these two chips here on the left, that's bank E0, and these two chips on the right is bank E1. So if you have bad RAM and it's saying E1, it is one of these chips, and decode the bit as I showed you with the calculator, and then you look in the schematics to figure out which of the two chips it is, because 4 bits are on one and 4 are on the other. So hopefully that knowledge is helpful to someone who's in the future repairing their 2GS. And then don't forget, if you're gonna make a ROM adapter like I did, you gotta use the right images, otherwise you're gonna be stuck with a machine that doesn't work, just like I was. Of course, I will put all the links for the stuff that I worked on and showed here in the description below. If you like this video, I'd appreciate a thumbs up, subscribe, all the usual stuff. Don't forget to check out my second channel, and a huge thanks to my patrons whose names are scrolling up the side of the screen. So that is gonna be it. Stay healthy, stay safe, and I'll see you next time. Bye-bye.